Module 9. This is it. This is the last one. It's our last unit, and we're up to the practice test. Means the end of the school year is upon us. But before we get there, we got to get to this last test, right? Get to the last test. All right, I have the Module 9 review and practice exam here ready to do, and we're going to work these problems. There's only 10 this time, short practice test. All right, we can get through this. Means the exam may not be too bad. I have not looked at it yet, but if there's only 10 on the practice test, there can't be a whole ton on the actual exam. So let's get started. Working with our circles here. All right, number 1 says Amy and Fraser walk inside a circular lawn. Point O is the center of the lawn as shown below. So here's O, that's the center. We have a lawn that's in a circle. They must live in the middle of a roundabout or something here. Amy walks from point B to point C along the segment BC. Okay, so along the segment, let's go ahead and just kind of draw that. So from point B to point C, so walks along that segment right there. Great. Fraser walks from O to point A. So he goes here. All right, so he goes there. I'll go ahead and draw the arrow. The direction is walking. Okay. Which statement's correct? Both Amy and Fraser walk distances equal to the diameter. Well, Amy certainly did, right? The diameter is all the way across the circle, but Fraser did not. Amy walks a distance equal to the radius. Well, we don't have to go any farther. We know she didn't walk the radius. She walked the diameter. Both Amy and Fraser walk distances equal to the radius. No. Amy walks a distance equal to the diameter, but Fraser walks a distance equal to the radius. There we go. That's just simply knowing what a diameter and knowing what a radius is, and then reading carefully. All right, which statement best describes a secant of a circle? Okay, so when we have a circle and we have a secant line, it's a line that just cuts through it somewhere. It does not necessarily go through the center. That would be a diameter if it did, but it's just a line. So it's a line that touches only one point? No. It's a line that joins a point on the circle with the center? No, that'd be a radius. It touches one point, it'd be a tangent line. It's a line that divides the circle into two equal halves. No, that would be a diameter. A diameter would divide into two equal halves. It's a line that intersects the circle at 2 points. Sure, just 2 points. It could go through the middle, but doesn't have to. Just somewhere at 2 points. All right. 2 questions down. Let's move on. Next page. Look at the inner and outer rims of the circular plate shown. Okay, so the outer rim is easy, but the inner rim, we draw this. Okay, got to trace it around. Okay, that's kind of the inner rim, make it a little bolder. What are the inner and outer rims called? Well, we have the outer rim and the inner rim. Are they concentric chords? No, a chord is a point from one point of a circle to another point. Like drawing that would be a chord. These are not concentric chords. Are they concentric circles? Yes. They are. One circle inside another one that has the same center point, concentric circles. Concentric radius, no, that's not a radius. Concentric secants, we just looked at secants on that. These are concentric circles. All right, some of these questions are not going to be very difficult, it appears. All right, so the circle shown below has AB and BC as its tangents. Okay, those are both tangents. They only touch the circle in one place. It says if the measure of arc AC is 140 degrees. Okay, so we have to assume that they are talking about this right here because there's 2 different ACs, right? Because it could be talking about this orange one from A to C. But I would assume that would say major arc there because this is the minor arc. When we're just talking about the arc, we usually mean the closest one. A to C, the closest way, unless they say major arc. And since it says 140, that's less than half of a circle, right? 360 is half a circle. So that's less than half a circle. Must be talking about this 140 degrees right there. So it wants to know what is the measure of angle ABC? This right here. Well, to find that, first, we need to know what the orange arc is. Well, since a circle is 360 degrees, and this is 140 of it, what's left? 360 minus 140 equals 220. So this is 220 degrees out here, 140, 220. So to find this, we have to subtract these first. So 220 minus the 140 is 80. And then we got to divide it by 2. 80 divided by 2 is 40. That is a 40-degree angle. We subtract the inside arc from the outside arc and then divide by 2. 40 degrees. All right. Number 5. We are almost halfway completed. A quadrilateral PQRS is inscribed in a circle. There it is. PQRS inscribed in the circle, as shown below. What is the measure of arc PQR? Let's the arc is in the circle and from P to R. So they want to know how big is that yellow arc right there. Okay, well, we know that arc is going to be double whatever this angle is. Because this angle touches the edges of that arc, right? Because this is the angle that goes from R to P. So whatever that angle is would be half of this arc. So if we can figure out what that is, we know this is going to be twice. Well, one thing we know about a quadrilateral inscribed in a circle is that the opposite sides have to equal 180 together. So 70 plus 110 equals 180. This has to be a 110-degree angle. So if that's a 110-degree angle, that means this arc would be twice that, or 220 degrees. 220 degrees. All right. What step is needed when constructing a circle inscribed in a triangle? So that's when you have a triangle and you go and you inscribe a circle inside of it that only touches it in 3 places, right? We get our compass out. We got to find our angle bisectors, right? And wherever those angle bisectors meet would be the center of our circle, right? The angle bisectors. So right there, angle bisectors. This is perpendicular bisectors. For perpendicular bisectors, this would be a circumscribed circle. Circumscribed circle. And that's when we had a triangle and we made a circle that was outside on the 3 points of the triangle. When we constructed that one, we used perpendicular bisectors. Okay. And this says construct the midpoints of each side. We don't do anything with the midpoints. Construct the altitude of each angle. We don't do the altitudes. These are the 2 things we do. We either make a circumscribed circle with the perpendicular bisectors, or we make an inscribed circle with the angle bisectors. All right. If you know those, there's just one question here. Probably just one on the test then, maybe. You think? Perhaps. Number 7. Which equation could be used to solve for the measure of angle P? Okay, so that's right here. This is angle P. All right, so it's labeled as y degrees in there. And how could we find it? So this says y plus x equals 180. Y plus x. There's nothing that says those equal 180. That is not true. How about y plus w? Y plus w. Okay, these are opposite corners of the inscribed quadrilateral. So that is true. Those would equal 180 degrees. So we could use this equation to find that. So all I have to do is figure out what W is, and then we can figure out what Y is. These others deal with Z. There's nothing dealing with the Z in there either. That has nothing to do with anything. It's just that these 2 opposite ones. Now these would also equal 180. X plus Z would be 180, and W plus Y would equal 180. All right, a circle has its center at 1, 4 and a radius of 2. What is the equation of the circle? Here's our choices. Well, the circle, remember, is x minus h squared plus y minus k squared equals the radius squared, where hk is the center and r is the radius. So if hk is the center and r is the radius, this is our equation. Now we know the center is 1, 4, so we're looking for x minus 1 and y minus 4. We know the radius is 2, so 2 squared, which is the same as 4. 2 times 2. So x minus 1, x minus 4. So it can't be that one or that one. 1 equals 2, 1 equals 4. It's 2 squared, radius squared. So 2 squared, 4 would be the one we're looking for. All right. 2 problems to go. Here's number 9. What is the arc length of CD in the circle below? So how long is this right here? Okay, what we know is the radius is 8 feet of this circle. And this is a 35-degree measurement of that arc. So if we wanted the distance all the way around the circle, that is either the diameter times pi, or if you don't have the diameter, 2 radius times pi, because 2 radius would be the same as the diameter, right? Well, we do have the radius, so 2 times 8 times pi would give us the entire circumference. 2 times 8 times pi. But we don't want all of it. We just want this piece of it. How big is this piece? Well, it is 35 out of 360. Out of the 360, we only want 35 of it. 35 out of the whole 360. Our calculator will give us an answer here. So, all right, 2 times 8 times pi. Okay, 2 times 8 times pi times, and put parentheses, 35 divided by 360. So 35 3/60ths. And that's going to be 4.88692. So it is about 4.88 is one of our choices right there. It's about 4.88. Should round up to 4.89, but of the choices they give us, that is the closest one, 4.88. Okay, last problem. What is the area of the sector? Okay, this is the same circle we just had. Radius of 8, 35-degree sector, slice of that. And what is the area? Well, the area of the entire circle, right? Area equals pi r squared. Although this pi are round, pi r squared. So the area of this entire circle would be pi times 8 squared, or 64 pi, because 8 times 8 is 64. 64 pi would be the entire thing. But we don't want that. We want 64 pi times just 35 3/60ths, right? Or 8 squared pi times 35 3/60ths. But I went ahead and simplified that to be 64. 8 times 8 is 64. 64 pi times 35 3/60ths. That's the ratio. That's the portion that we want of that whole thing. So now our calculator says 64 times pi times 35 3/60ths equals, the area is 19.54 or 0.55. Again, they have the 5.4, 19.54 square feet. That would be the area of this. The whole thing would have been 64 times pi. So the whole circle is 201. But we just want a piece of it, right? We want less than a tenth. 35 is less than a tenth of 360. Less than a tenth would be 19.54. All right, that is it. Quick and easy this time, dealing with circles. If you have your formulas written down, write down those formulas that are at the end of each of the lessons. You can have your notes ready, and this should go pretty simple. Have on there, what is a secant line? What's a tangent line? You can draw them and put what that is. What is a chord? What's a radius, a diameter? Know those things, and then know these formulas for finding the arc length or the area of a sector length that we just did. And I think you can score well on this one and really finish strong. A great way to wrap up the semester. Remember, if you earn an exemption for the final, you can take the final without it lowering your grade. It can only raise your grade. That would be wonderful. So make sure you have all your assignments turned in. All right. This week, this practice test is your assignment. It does not count for a grade, but it is an assignment. So if you don't have this turned in, you'll have a missing assignment and have to take the final. Practice tests are assigned for you to do. It's an assignment. Okay, let me know if you have questions, and do work you can be proud of.